Hi everybody, welcome back once again to this channel. This is a special edition on number patterns. We're just going to explore this quite very interesting question. If you're new to the channel, make sure you have subscribed. YouTube is saying 70% of the people who watch our sessions haven't subscribed. So just ensure you have subscribed and just turn on that notification bell so that you can be notified every time when we upload. Okay, without wasting any time, let's get into it. Okay, so here's the question. We are given 12 cos beta plus, um, 5 plus sine beta, 6 tan beta are the first three terms of a geometric sequence where beta is an obtuse angle, right? Remember, obtuse angle is between 90 degrees and 180, right? Show that the sum where n is equals to 1 up to infinity of Tn will be equals to 9 into 1 minus root of 3. Okay, so the question has 5 marks. Okay. You can clearly see from this sum here that there's nothing like beta there, right? So basically the first step for us would be to try to solve for that beta so that we substitute, we get the actual numbers, then we can go and get that sum. Okay, so that's perhaps the main thing in this question. So how do we solve for beta in this question? Obviously we can use the idea of a common ratio in a geometric sequence that T2 divided by the previous term, which is T1, will be the same as T3 divided by the previous term, which is T2. Okay, what is our T2? Our T2 is 5 plus sine beta divided by the first term is 12 cos beta, right, is equals to T3, it's 6 tan beta divided by T2, which is 5 plus sine beta. Okay, then we can go and cross multiply and solve for beta. When you cross multiply here, you have 5 plus sine beta multiplied by 5 plus sine beta. Okay, this is equals to 12 cos beta, which is now multiplying what? 6 tan beta. Okay, so perhaps we can expand there and simplify. 5 times 5, 25. 5 times sine beta, 5 sine beta. 5 times sine beta, 5 sine beta. Those two, 5 sine beta plus 5 sine beta will be 10 sine beta plus sine squared beta. Okay, so that's when you simplify that part. Okay, this is equated to 12 cos beta multiplied by 6 tan beta, which can be written as sine beta over cos beta. Okay, that is your tan beta there. We can write it like that. So cos beta and cos beta will cancel. Then I have 12 times 6, which will give me 72 sine beta. Okay. So now I have my equation in this form. I can take 72 to the other side. So I have sine squared beta plus 10 minus 72. You know, 10 minus, when you take this to this side, it has a like term. 72 minus, 10 minus 72, it's minus 62, right? So this will be minus 62 sine beta plus 25 is equals to 0. Okay, so now we have to solve for sine beta. You can see it's giving you sort of like a quadratic equation, right? So you can outline, so we can use a quadratic formula to solve for sine beta, right? In this case, if you let sine beta to be p, you'd clearly see that that will give you some sort of like a quadratic equation. Can you see something like this equated to 0? Okay, but we won't do that because of time. What we can just do, we can just highlight what is our a. Our a is 1. What is our b? Coefficient of sine beta, which is minus 62. C is 25. Then use a quadratic formula. In this case, you can't say x equals to minus b plus or minus root of b squared minus 4ac over 2a, right? Because you don't have x here. Instead, we are solving for sine beta, so we say sine beta instead is equals to this. Then you just substitute minus into minus 62 plus or minus root of minus 62 squared minus 4ac, right? C is 25 divided by 2 into A. Okay, then you just punch your calculator, you'll get sine beta is equals to on my calculator I'm getting 61.594178, or sine beta, you know, sine beta is equals to, remember you use plus and or minus, so it's gonna be equals to 0.405889291, like that, right? So for this part, for this one here, if you check arc sine of 61 point something, it's going to be error, right? Here you get error, right? Because I mean this is beyond the scale of sine. Remember, sine is the maximum at 1 and minus 1, so obviously there's no x that will give you, I mean beta, that will give you that. So this is much reasonable, so we can solve for beta by saying arc sine of 0.405889291, right? Then we can get the answer for beta. Let me just create some space here. So when you solve for beta there, you'll get your beta is equals to 23.946 degrees, right? And you can see the angle that you are given, it's an acute angle, it's less than 90, but here they want an obtuse angle, right? So obviously to get the obtuse angle, you'll go where sine is positive. It's positive on the second quadrant, right? Second quadrant defined by 180 degrees minus beta. Okay, so we can answer beta in that quadrant, 180 degrees minus 23.946 degrees, right? Because they told us that beta is an obtuse angle, so you just say 180 minus that as our reference angle, then we get 156.05 degrees. Okay, so that is your beta. So after finding your beta, you can just go and find that sum to infinity. Okay, to show that sum to infinity will be 9 into 1 minus root of 3. Okay, so obviously to get sum to infinity, because if you check, what we really want to show is that the sum to infinity is equals to this, right? So sum to infinity is equals to a over 1 minus r, right? What is our a? Our a is our first term, which is 12 cos beta, okay, divided by 1 minus, what is our common ratio? Common ratio r, it'll be the second term divided by previous term, which is like 5 plus sine beta divided by 12 cos beta. Okay, so that's your r, which is like 5 plus sine beta divided by 12 cos beta. Okay, so now we can basically now go and substitute our beta, because we know our beta is 156.05, right? So we say 12 cos 156.05 divided by 1 minus, where there is beta, I'm just substituting that, 156.05 divided by 12 cos 156.05. Okay, I'm just gonna punch this on my calculator and see what I get. So I'm getting minus 7.3460833329. Okay, so we can just go and confirm with this. What is 9 1 minus root of 3? Does it give us the same answer? So you can just check on your calculator, 9 into 1 minus root of 3, and that will actually give us, let's see, so we're gonna get minus 6,58845, like that. Okay, so I think perhaps the issue might be with some roundings, but possibly that is also quite closer to that. Okay, the main idea is that you have to use common ratio to actually solve for beta. After finding beta, you must go to the quadrant where beta will be obtuse, and then you can just go and calculate your sum to infinity. Okay, I hope you find this helpful. Don't forget to like, share, comment, and subscribe. See you soon. Bye.